Okay, so now that we understand the product, we understand why we are doing this distributed and why we come together to fix all those issues that need fixing. Essentially what we are creating, this is a security policy, this is a security mechanism that not only allows us to understand that this is a very secure way to store digital assets in order to prevent any issues with them, but it is also a safety. Because today, if I lose my SIM card, I know that I will go to the operator and he will make sure that my phone number stays with me. So when you have this kind of a situation, even if you lose your phone, you might not get access to your data if you didn't back it up, but you can go and restore your own mobile number. Using these distributed policies that we will have, we will be able to restore everything that we previously had. So it's not only security in the sense that you will not steal my money or my transactions will not be safe or my data will be visible. It is also in terms of safety, making sure that no one steals my identity and I can always regain access to my identity if there is a need to do that because I lost a few things. So we take this entire project and we say, okay, we need our contributors to contribute in order for us to do this. It will take us a year. This year we'll have 4 milestones. The first milestone, we say, okay, we will have a development kit ready for anybody who wants to start joining this revolution and start developing things. The first phase, around 3 months after we start the project, we will have the development kit. Those are 5 SIM cards each one will get. These SIM cards will have roaming and data coverage and telephony services and number portability in a few locations. So it will allow the developers to start working with those SIM cards on the open network that we will provide. So today you can write kernel extensions, you can write application for mobile, but you cannot write application using APIs for your network. In the first phase, when we will deliver this development kit, it will come with full APIs to the network. If you want to write a program that checks every incoming number against the database and does not allow for spam calls to get in, the same for SMSs. If you want to do parental control, if you want to do personal firewall and want to allow which ports are incoming and outgoing, if you want to do deep packet inspection or antiviruses, the same things you can do today with your network in your office, your network at your home, your firewalls, the application within the firewalls, your phones, application within your phones. So we are opening the network and allowing everyone who gets our development kit to start writing those applications using the open API that we have for this cellular network. That's the first step. The second step will have the distributed policy. So we can define each action that comes to mind, what will be the policy associated with it. So you can say that you have, you can change your identity if I lose my SIM card when the operator approves it, but also I need 3 of my best friends, 3 out of my 10 friends to approve it. So you control a policy when you say who can do what. So another example would be that, I'm just giving a financial example because it's easy to explain. If I want to approve a transfer of $1,000, I need 2 of my SIM cards, of my inner circle SIM cards to be active. Just turned on, you know, my wife's SIM card, my son's SIM card, and my lawyer's SIM cards or my brother's SIM cards just turned on. But if I want to transfer $500,000, then I can go with a more complicated policy that says I need 4 of them turned on, I need 2 of them to accept the push notification and approve it, I need 2 of them to receive a one-time password via SMS and to approve them, and I need 1 of them to be a clickable hardware where my lawyer just goes into the safe and click approve on that specific button. So not a push notification, rather a button, a physical button to approve that transaction. I can also say that if I want to transfer up to $1,000, I just need to be in my country. You know, if my SIM card is in that country, I don't need anything else. But if I'm out of the country, then I can do some more complicated. So those distributed policies, they have the who and the what. X amount of Y doing certain things. such as being in a specific location, being in the area of a beacon, being very near field, very close to an NFC chip, which can be stored in a vault. You know, I can have $1 million put in one account, and I can take the private key, and I can put it in a policy that says, you know, you need to take this chip out of the vault without NFC to it, and I have $1 million in my vault. So we can have those policies, X out of Y, and what happens and where it happens, all of those events. So that's the second step. The third step now becomes the distributed key management SDK, which means that we are utilizing the SIM cards and the operator the same way that they are communicating with a secured and encryption way today to control roaming, to control the applications on your SIM card, to replace them, to activate them, to send commands to your SIM card, to do over-the-air commands. We will use the same trusted mechanism today to communicate via the signaling, not via the internet, via the SS7 signaling, the backhaul of the operators, which is a closed garden. We will use that to communicate with the SIM cards in order to exchange communication. So we will have this SDK that each app developer can use. This SDK will use HTTP commands to one of our core elements, which will talk signaling, SS7 signaling with the SIM card to try and reassemble all of the segments of the keys that are needed. So I can reassemble my keys, which means that if I lose one SIM card out of my 5, or I lose 2 SIM cards out of my 5, I'm okay, I can replace them. I haven't lost everything. If I lose 5 of my 5 SIM cards, if that is the policy that I have, you know, I'm dead in the water, I lost all access to everything. But if I have 5 SIM cards or 10 SIM cards, that is my policy. Even if I lose 1, 2, 3 or 4, it doesn't matter, because everything is distributed among those SIM cards. So again, we have this SDK, and any app developer can use this SDK to do an HTTPS request to say, this is the transaction that I want to sign, this is the policy that I want to comply with, please use this and sign it. Our decentralized over-the-air gateway will look at this request, will look at the policy, will see who we need to communicate with, and start sending signaling over the SS7 network to reassemble the key and to send it secure, fragment by fragment, encrypted and secured to a specific SIM card, which is currently acting as the master SIM card, that will also get the transaction. It will do an internal signing. The private key never leaves the SIM card itself. The full reassembled private key never leaves the SIM card itself. So once we finish with all the reassembly, you know, getting this part, so I'm saying this SIM, take your segment, encrypt it with the public key of this SIM, now ship it over a secured peer-to-peer encrypted way, so using the over-the-air. So I'm getting this, I'm shifting it here, and now only this SIM card can open that specific segment. This master SIM card will reassemble the segment, and eventually will have a full private key. Now this SIM card will also get the transaction. He is able to sign it with the private key he currently holds, take out the signed transaction, forget about everything, all the segments now are lost. I will forget the entire reassembled key, and I will take this signed transaction, return it to this distributed, decentralized OTA gateway, and now this OTA gateway, over the gateway, we will be able to return this signed transaction via HTTPS to the SDK who initiated this signing request. So in the first phase, we say full API, open network, we give the development kit, you get 5 SIM cards, you start developing on our API. The second part, we give access to the distributed, decentralized policy running on the internal network that we have. The internal network, this is a corporate distributed ledger technology, and it is only for the operator members of our network. You cannot go and say, I want to be a master node in this network. You can't. You need to be an approved operator within the fixed network. So for the third stage, we go and we say, okay, we are doing the distributed key management with the SDK, and we're allowing to app developers to use this SDK and leverage all the capabilities. The first milestone, which is the public launch of our MVP Fix 1.0, would be an integration of all these components with other service providers that will spend this time to develop application user SDKs, to develop hardware, cold wallets, and other types of wallets using all the components that we'll build. So when we go to market with the MVP for a bigger adoption, we would go with an ecosystem of everything that we've developed, but also with third-party development. So we're saying this is the milestone. Everybody, please sync, because on this launch date, we want your product and your product and your product to be available with everything that we provide. So this is the first milestone for 1.0. Now we have clear visibility on what happens in 2.0 on a later stage that says, okay, we want to step out of this corporate DLT, distributed ledger technology, and say, let's step out of it from the closed telecom garden and let's go with the public ledger, open for the public, used by other services, external to the operator and everything. And this is the place where you go to the mass adoption. This is the place where the use cases, blow away, and this can be used for basically anything.